Welcome to Chapter 4. I'm Miss Fleming. It's been brought to my attention that I'm not introducing myself on these videos, so let me clear that up. This is the first lesson in Chapter 4, 4.1. Let me tell you what's in Chapter 4. Chapter 4 is mostly about working with polynomials. And we're going to multiply polynomials, we're going to divide them, we're going to subtract them, we're going to do some things where the polynomials are going to help us solve geometric figures. So this is mostly a skill chapter. Then we get towards the end and we're going to revisit rewriting formulas and solving linear equations. And we're also going to go back and we're going to work on domain and range again, but this time it's going to be in word problems. So that's what you got to look forward to. All right, today is Skinny Friday, so this is a pretty short lesson. We've got some vocabulary. Again, this is 4.1. First of all, we need to know what a monomial is. Okay, mono means one. So a monomial is a number, a variable, or any combination of numbers and variables joined by multiplication and division. That's it, nothing else. Okay, let me turn the pen on so I can at least follow along a point while I'm doing this. All right, so right here, I've got a number by itself as a monomial. I've got a variable with an exponent, it's a monomial. And then I've got a number, which is a coefficient, and two variables. And this says 23 times x squared times y. So this is also a monomial. If I had something to look like this, let's see, that's not what I want. Let's go over here and press pen and turn on the color. If I had something like this, x divided by 5, that is also a monomial because it's a variable divided by a number. So multiplication or division, nothing else. Okay, then I have my next word. This is a binomial. Okay, mono means one, bi means two. So this is two monomials and they're going to be joined by addition or subtraction. So I have a monomial of x, a monomial of 7, and they're joined by addition. I've got parentheses around this, which is how you're going to see binomials a lot. They are going to come up frequently in parentheses. And you'll see why later on. But I've got a monomial of here of negative 3x squared minus a monomial that is 15. So again, it's got two monomials. I'm joined by addition or subtraction. And then I have the general term. So mono is one, bi is two, poly means many. So this is many monomials, any number of monomials joined by addition or subtraction. Okay, let's erase this and get into the lesson. And let's turn the pen back on. Maybe. All right, we are going to, in the course of these lessons, we're going to learn a whole lot about the laws of exponents. And the first one we're going to learn in this lesson is the product law of exponents. And let's see if it will finally let us turn a pen on. Yes. Okay. All right, product means multiplication, right? So put multiplication up there. There we go. Okay. The product law is about multiplying a monomial times a monomial. And how you handle this, it involves the law of exponents. When you multiply a monomial times a monomial, you do simply this. You multiply the coefficients, but you add the exponents. So here's my first example. I've got a 2x times a 5x. 2 and 5 are coefficients, and x times x. They have exponents. You may not know it, but they do. This has an understood 1, and this has an understood 1. And I'm sorry about that little tail in that. Let's see if we can get rid of it. Okay, so it says that I am going to multiply the coefficients. 2 times 5 is 10. And I've got an x with a 1 and an x with a 1. I'm going to add the exponents, so 1 plus 1 is 2. That's how the law of exponents works. Okay, down here I've got negative 3a squared times negative 7ab. Okay, so again, everything has an exponent, so these have 1s. I'm going to multiply the negative 3 and the negative 7 because they're coefficients, and a negative times a negative is going to give me a positive 21. And I've got an a to the second power and an a to the first power. 2 plus 1 is 3. And while I don't have a b in this term, I can't throw that b away, so it doesn't have anything to do but just come along for the ride. I can keep the 1 or not, but that's what it is. All right, this one looks funny. And we're like, okay, well, I've only got one monomial there, raised to the second power. Well, this is anything raised to the second power is being multiplied to itself. Anything being squared. So x squared is equal to x times x. So I'm going to see that there are two monomials here because it's 5y cubed times 5y cubed. Write that here. Okay, so 5 times 5 are the coefficients. That's going to give me 25. I'm going to add the exponents. So 3 plus 3 is 6, and we are done. Okay, now we're going to take the law of exponents, this product law that applies to monomials, and we're going to use it with the distributive property and monomials times polynomials. Let's erase this. All right, so I'm going to use the distributive property to distribute this monomial, 5n, to everything that's in here. Now this is a polynomial. It's got three terms. It's 3n squared minus n squared plus 8. But when I multiply this, because I'm distributing this, I'm actually multiplying a monomial to a monomial. And that's what I've got up here to show you. So I've got 5n times 3n cubed is up here, and it's going to go into this box. Minus, and then I've got 5n times n squared, and it's going to go into this box, and 5n times 8. So that's the relationship between the product property with exponents. Okay, again, this has an understood 1. So let's go ahead and write that in. So 5 times 3 is going to give me a 15. And 1 plus 3 is n to the 4th power. Okay, there's an understood 1 in front of here that's its coefficient. So 5 times that is going to give me a 5. And don't forget that this n has an understood 1 as its exponent. So 1 plus 2 is going to give me n to the 3rd power. Okay, the fact that there's no variable here doesn't matter. We're going to multiply the coefficients. 5 times 8 is going to give me 40. And that doesn't have anything to do but come along for the ride. And looking along here, I don't have any like terms to combine, so that is my answer. Okay, we've got a couple more examples. So down here, I draw these loops so that I can keep track of what I'm multiplying. If you don't want to draw them, that's up to you. So that goes to that. That goes to that. And that goes to that. And it helps me keep track. I've got 3 monomials in here, so I'm going to multiply 3 times. So 5x times negative 3x cubed. First thing I'm going to do is make sure I've got all my exponents. And did it change color? It did. All right, this x has an understood 1. This one has a 3, that one's got a 2, and this one has an understood 1. Okay, so 5 times negative 3 is going to give me a negative 15. X to the first power times x to the third power, 1 plus 3 is going to give me x to the fourth power. 5 times negative 5 is negative 25. And that x to the first added or multiplied to this x squared, 1 times 2 is going to give me x cubed. Okay, there's nothing for this except an understood 1. So that's going to give me plus 5. And x times x is x squared. Okay, let's write in the understood ones here then. This has got an understood 1. This has an understood 1. This has an understood 1. In addition to that, I've got an understood 1 right here because that's a negative x, so it's got a coefficient that is a negative 1x. Okay, so multiplying this through, I've got that one times that one, that one times that one, and that one times that one. Negative 1 times 2 is going to give me a negative 2. Okay, the x and the y, they're not going to combine anyway at all, but they are both along for the ride. So it becomes x times y. I've got a negative times a negative, even though that's a plus sign. So that's going to give me a positive 3. A negative 1 times a negative 3. And I've got an x to the first power times an x times to the first power, so that's x squared. Negative 1 times negative 7 is going to give me a positive 7. And x to the first has no x's here, but we can't throw it away. It's along for the ride. All right, so if you'll notice here, other than, we've got an x now in every term, and this one increased by 1, but look what this negative 1 did. That positive 2 became a negative 2, that negative 3 became a positive 3, and that negative times a negative became a positive. Back, all the way back in the first chapter, we had a multiplication property of negative 1 that said if you multiply it by negative 1, you get the opposite. That's exactly what happened. Okay, I'm going back to my red so I can mark in all my understood ones. And it looks like I've got one here, and I've got one there. That one's not great. Let's clean it up a little bit for clarity. It goes with the A. Okay, go back to the blue pen. All right, so a squared times 3a squared times ab squared, and a squared times negative 4b to the first power. All right, this has a 1 in front of it. We won't have to write it down, but that's going to bring the 3 along. A squared times a squared is going to be 2 plus 2 is a to the 4th. Remember that we multiply the coefficients, we add the exponents. Okay, no coefficients here, but 2 plus 1 is going to give me an a to the 3rd power, or a cubed. I don't have a b here, but this still comes along for the ride. Nothing to multiply with the negative 4, but it comes along for the ride. And the a squared and the b to the 1st both come along. So you don't throw anything away. Okay, back up here, let's write in our understood ones. That way we don't forget to add them in. And we've got 2 of them. All right, this is going to multiply here, here, and here. Negative 3 times negative 2 is going to give me a positive 6. X times x squared, 1 plus 2 is going to give me x cubed. Okay, that's a negative times a positive. I've got an understood 1 here, but that tells me I'm going to have a minus 3 and x to the first times y to y cubed, or y to the third. Those are both just along for the ride. Nothing's going to change. So the only thing that changed here, well, no, we've got more than that. And then I've got negative 3 times negative 5 is a positive 15. And x times x, 1 plus 1 is x squared. Okay, a couple more things. We're going to do some geometric figures as promised. Okay, clear this off. And we're going to scroll. Here's the geometric figures. All right, I have here a rectangle, and this is actually a square. These lines right here, those say that those sides are equal to each other. So if the sides are equal to each other, and these are all right angles, this is actually a square. So we're going to look at it a couple of different ways. But let's look at the rectangle first. Okay. Use the distributive property to find the area of each rectangle. Area is equal to length times width. Traditionally, this is the long side, so this would be the length. And this is a short side, so it would be width. But I'm going to want this monomial in front. And the commutative property says that I can do that because I'm using nothing but multiplication. So I'm going to go ahead and write this as 4x squared, and I'm going to multiply this entire binomial. So I've got 3x squared plus 2x. And I've got an understood 1 right there. So 4 times 3 is going to give me 12. X squared times x squared, they're both x's. 2 plus 2 is 4. 4 times 2 is 8. And that's x squared, and I've got x to the first, so 2 plus 1 is 3. So my area of this rectangle is equal to 12x to the fourth plus 8x cubed. All right, now I could use length times width, and I know these are all equal sides, so this side is 3z to the fourth. This side is 3z to the fourth. And this side, now I draw those lines through there so they don't look like 2's. This side is 3z to the fourth. All right, now, I can use length times width, but there's also a formula for the area of a square. So if I look at just the square, wow, that looks great. There we go. The area is equal to side times a side. This is a side, that's a side, side, and side, which is, side times side is going to be side squared. So I can write this as, the area here is going to be equal to 3z to the fourth times 3z to the fourth, which we know is this. This is all the way up in the first box when we talked about the product property and we looked at something like this. So that follows this part of the formula. And now I can break this down to say it's 3z to the fourth power times 3z to the fourth power. And that's going to give me my final product. 3 times 3 is 9. And z to the 4th times z to the 4th. I'm going to add those 4's together to get 9z to the 8th. All right, so we use a distributive property to multiply polynomials, and we learned the product law of exponents, which says that as long as you're multiplying monomials, you multiply the coefficients and you add the exponents. And that is the end of this lesson. Over and out.